Hey everyone, Joseph again, trying to say that to prove the fact of inertial spatial fields, what you should urge your professors to do is make a hoop, right? And I've already thought this through, and I tried filming it, and it didn't come out yet, or it didn't come out at first. So you make a hoop, not with a net in it. But then you make 3 buckets that would go like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. So when you do that, you're getting a bunch of reactions all at once. What you want to do with those reactions is cut the bucket's bottom part out. I guess the whole bottom part would work, but with my preference, it would be a 90-degree angle that you do it to a basket or a bucket. After you do that, then you throw a ball through the hoop and make it land in one of the 3 buckets or baskets. After you do that, have it drop down, have the ball drop down to wherever it is with its own weight, and catch in a net. That's when you need a net that has a 45-degree angle. The principles of the 45-degree angle come from the Pythagorean theorem. This is dimensional 1 of space dimension. This is what I think. After that's already done, what you want to do is catch it like that and like this, and it should stop directly where it is. Right? That's what we expect, but it's gonna catch somewhere, and it's gonna come down. To get to the second spatial dimension, what you would do is you would fill a cup up with water that's underneath it, or a bowl up with water that's underneath it. It's gonna land directly in that area. You throw it through the hoop. The bucket catches it, and the bucket swings and drops it wherever it should drop it. Now you can line up buckets for it to be lined up for, and then after that, what you need to do is find out why that's inertial spatial dimension. So the water will be touched, and whatever the frequency of the water is given to it by a droplet, even by a droplet, is like an echolocator as to what a ping is. Or maybe not a ping, but a gravitational rotational mass. I gotta think this up before I say it out loud next time, because I want to be right. It's just an inertial field, inertial spatial field. So if it's coming at you like this, the inertial spatial field is somewhere out there around it. Wherever it's coming back to is wherever it started, or wherever it stops in midpoint is the inertial spatial field. So when you figure that out, you want to urge your professors to think about it and tell them. Say, hey, look, I think this is a cool idea. I think we should try this once or twice. And, make a game out of it or something in class, that at the end of the class, that whoever does that Or we can make the perfect inertial grounding, which would be a mass that drops straight down. It bounces straight up and back and down, up and back down, back down. That's buoyancy. That's the buoyancy of whatever happens. So that is gravity pure. That's pure gravity. But on this planet, it wouldn't be called pure gravity. It would be called pure gravitational pull or rotational pull or something like that. But it's gravity. So you can make a game out of it and do whatever you guys want to do with it later on. If you guys are having fun with physics, just want to make actual fun things happen in school, just let them know. All right, Joseph Alvarez, sign out.